Hello everyone, good morning, and how are you? Hope that everything is well with you. Um, Good morning, yes. Uh, okay, as you know, according to the most of the strategies in Turkey, uh, our classes would be online. Um, However, in uh, Corona pandemic time, we tried to have online classes, and we're familiar with the problems related to the online classes. But anyway, um, the number of the attendance of this class is so high. It's a good opportunity for us to having this kind of class because I think we can transfer the concept of the course better than we have our face-to-face or traditional classes. Anyway, hope that we can come back to our normal situation, but in that time we can decide to the rest of the classes to be online or face to face. As you remember, for the ones who was present in class in previous session, we had a brief introduction about the exam and the course syllabus, but today, I want to talk about them in detail, meaning that about the scores related to the final exam and also about the syllabus. We will take in detail, and then we start to talk about first chapters material. So, yes. Uh, about this course, we will have most probably we will have a midterm exam and also final exam related to our situation. Um, uh, you know that the laboratory part of this course is omitted because of the high number of the students and also the problems that was in laboratory related to having access to the different devices. So they delete the laboratory part. But about the grading, then we decided to have a final exam, and most probably we will have midterm exam. And the references that I prefer let me check the syllabus, yes. That I prefer for this course and is so useful is the AVR microcontroller and embedded system using assembly and C by Muhammad Ali Mazidi. Anyway, I start the session by having a brief introduction about the syllabus. However, previous session we didn't go in detail about the syllabus. Now I want to mention the syllabus and explain about the microcontroller, what is microcontroller and microprocessor, what's the difference between microcontroller and processor, and so on. Of course, we will have yes, previous session we started actually our class, but I didn't explain anything because the number of the attendance was less. So we decided to start the course from the course material actually from this session. If you have any question, you can ask after class, please. About the syllabus, we will have an introduction, and also we will have application-based introduction of microprocessors and microcontrollers. Then we will talk about the differences between the microcontroller and microprocessor. After that, we will talk about AVR microcontroller and its history and features will be discussed. Then we will pay to explain about AVR microcontroller architecture. As I said in previous session, after having experimentation about microcontroller, the different types of AVR microcontroller, its features, and also the architecture, the different components of a microcontroller, we'll start to our coding by microcontroller and using for different applications. Then for that reason, for that target, we start to have a review about C language. However, I know that you're somehow familiar about C language, but for having a good coding, we need to have a review about the language which is required to our coding. So after that, we will have different applications for AVR programming. Actually, the AVR that we are using in this course is Atmega 32 or 16. And according to the course syllabus, if we have a sufficient time, we're trying to cover all of the application for our Atmega 32 or 16, meaning that we will talk about input-output ports. We will have application of LCD. Then we will pay to talk about timers, counters, and if we have sufficient time, we will pay to different types of keypads. And then also we'll have another application, which is analog to digital or digital to analog converter. And at the end, motor control by PWM. Actually, as I see, I said that we're trying to work with Atmega 32 or 16. If we want to consider one of them, actually, because these two types of Atmegas have the same features, then by considering one of them, actually we can use for different applications the other ones. Because Atmega 32 and 16 have the same features, only with small differences with each other. That we will talk about them in next slides. But what is microcontroller? Actually, microcontroller is a single chip which is called self-contained computer. Why we're calling it as a self-contained computer? Because it's including several peripherals, and also it's including microprocessor or a CPU, which is actually considered as the brain of each kind of computer. So as you see here, this is considered as our microcontroller as a single chip. And do you have the cursor? Do you see cursor? Okay. You see that this is our microcontroller, and it's including microprocessor and the other peripherals. which all of them are placed in one single chip. When we try to talk about the microprocessor and microcontrollers differences, actually the main difference is related to their operation and their peripherals. What does it mean? You see that here. Really? Meaning that my voice isn't clear? Okay. Okay, we can wait for 10 minutes, and after 10 minutes, I try again. Most probably it will be solved after 5 till 10 minutes. Okay? Hello again. Could you please let me know about my voice quality? The problem was solved or not? Okay, okay. Then we're going to explain the next slides and the rest of the concept. Okay. We were talking about the difference between microprocessor and microcontroller, and we said that the main difference between them is related to their operation and peripherals. Actually, as you see in this figure, we have a microprocessor and also the other peripherals. All of them are placed in one chip, meaning that our microcontroller not only is including microprocessor, which is considered as the brain of our single chip as microcontroller, but also it is including different peripherals as input output port, interrupt, timer, serial and parallel ports, and different types of memories as random access memory or read-only memory. So here we have two other figures related to microcontroller, and the right-hand figure is related to the microprocessor, which is placed with other types of the chips for different purposes. As you see in left-hand figure, we have microcontroller. As I explained in previous slide, it's including a CPU as microprocessor, timer counter, clock, memory, input-output ports or interface, UART and other peripherals or would be in our one single chip, which is called microcontroller. But about the right-hand figure, you see that all of these peripherals are separated from each other. And for example, when we are using microprocessor and we want to create interrupt in our coding or delay in our coding, because, for example, we don't have clock or we don't have any other kind of peripherals which is inside in our microprocessor, then we need to add these extra peripherals to our system to create different tasks or different to have different usage of our microprocessor for different aims of applications. So as you see, we understand that microcontroller as a one single chip is including different chips inside it, and they are considered as peripherals which are placed in one single chip. But about microprocessor, we don't have the same situation. And for example, if we need clock, we should add another chip, or we should add UART, we should add different memories to our system to use it for different purposes and applications. Here we have some mentioned and noted differences between microprocessor and microcontroller. Actually, microprocessor, as I said, is a main part of any kind of computer, and it is considered as the brain of each computer. So, but we know that microprocessor is used only for processing of the data, and then because it is single purpose processing data task, then it is so faster than microcontroller. it can be used for general purposes. What does it mean? For example, for different applications, we can use a different microprocessor with different speed, with different value of size, and so on. It is expensive. Why we say that it is expensive with respect to microcontroller? Because we don't have microprocessor in usually. We don't have for normal usage. We don't have a microprocessor with this size of with the amount of microcontroller, and usually for large amounts microprocessor are used, but then when we're trying to compare microprocessor and microcontroller, it's better to compare it with the same features. So a CPU is a standalone. We have RAM, input, output, and timer, which are separated from our microprocessor. Moreover, about the microprocessor, designer can control the amount of RAM, and input-output peripherals because they are external chips that can be added to our microprocessor. Then we have authority to control the amount of RAM, and the other peripherals that can be connected to our microprocessor. But when we want to compare microprocessor and microcontroller with the same features, of course, microprocessor would be cheaper than microcontroller. This item is so important, and please don't be confused with this one, because here we are talking about the same features of microcontroller and microprocessor. And as I said, the microprocessor which are available in the market actually are made in and are produced in large amount, and they are not available in the amount of microcontrollers. But if we want to compare them as same features, of course, microprocessor would be cheaper than microcontroller. Then we can find that microcontroller is slower than microprocessor. It is a standalone operation. It is cheaper than microcontroller for the reason that I talked about them in a previous slide. And as you saw in the figures that I explained about them, all the CPUs, different types of memories, RAM, ROM, input, output ports, timer counter, and all of them, these peripherals are placed in one single chip with fixed amount. You remember in previous slide I said that when we are using microprocessor, we have authority to change the amounts because all of them are added to our microprocessor externally and aren't placed inside our microprocessor. But about the microcontroller, all of these peripherals are fixed inside the microcontroller, and then we can't change the amount of RAM, ROM, CPU, and other peripherals which are placed in one single chip as a self-contained computer microcontroller. So microcontroller is used for application in which cost, power, and space are critical, and it has single operation. Because the amounts of these peripherals are fixed, and for the specific operation they can be used. After talking about microprocessor and microcontroller, as I said in the syllabus, we will have history about the AVR, about different types of microcontroller, and we will pay to AVR microcontroller. In 1971, Texas Instrument Calculator on a chip TMS-1000 was a 4-bit microcontroller with built-in ROM and RAM. It was the first type of microcontroller that was produced in that time. In 1976, Intel company produced another type of microcontroller, which is called 8048, and was one of the first Intel company's microcontrollers. Then in 1980, this company, meaning that Intel company, produced another type of microcontroller, which is called 8051, followed the previous one, and became one of the most popular microcontroller families. And for several years, this kind of this microcontroller, meaning that 8051, was used in most of the industries, and also in most of the actually universities. It is used to tout for bachelor's in microcontroller course. But after that, in 1996, Atmel company produced the new family of microcontroller, which is called AVR, and was one of the first microcontroller families to use the one-chip flash memory for program storage. But about the AVR families, as I said, after talking about history of different types of microcontroller families, we said that we will pay on AVR family, and we will talk about Atmega 32 or 16 because of the same features that they have. AVR family are actually divided in three categories. A tiny AVR family, which is including 8 until 32 base or pins, and or including 16 family members. Then we have Mega AVR family. It's including 32 till 100 base or pin, and it's actually 23 family members. And the large amount of AVR family, which is called X Mega, and it's including also the same pins with the previous one, but with some differences about the features and amount that we will talk in next slide. Yes. Actually, the AVR family is divided in 4 main categories, but I mentioned only 3 ones. I start with 18, 8 tiny, at Mega, and at X Mega in previous slide. But AVR family actually had the first family, which is called 8090S series. These types of AVR family series actually are the classic members of AVR families, and with respect to the other ones have fewer features, and also they are including less words which are used in their structure. About a tiny series, these microcontroller chips are small in size, and as I said, they are using 8 to 32 base or pins, and have better capability than the first categories, and are mostly used in the system that they don't require a high port. And also it is including 8 bits. About Atmega series, actually, this family of AVR has more feature with respect than to previous one. These types of microcontroller families are self-programmable and can be programmed using adding sequence. It's also 8-bit, and it has 4 till 4 to 256 kilobyte program memory, and different families of these Atmega series are as 80 mega 8, 80 mega 48, 80 mega 60, 80 mega 32, and 80 mega 48, and so on. That, as I said, we will talk about these two ones, and I think it's so sufficient for you to having information about the AVR family for different applications. The other one, which is a large amount, and it's called at X Mega series. This category is largest and advanced one, and has 16 to 384 kilobyte program memory. As you see, the difference is between these two types are completely clear from the values related to their program memory. Also, this type, with respect to two previous type, Tiny and Atmega series, is including 16-bit. However, two other ones, the previous ones, are including only 8 bits. Here we have a fundamental database related to the meaning of word and byte. However, I'm sure that you have sufficient information about them because I used the term word here. I wanted to know what we mean with the word. Each of these are 1 bit, and the byte and word and the number of bits related to word and bytes are clear from this figure. So now I want to at first talk about different components of microcontroller. Then we will have explanation about each of these components. As I said, microcontroller as a single chip is including all these peripherals inside it itself. It's including memories. You see that this is memory sections. It's including RAM, ROM, EEPROM, EEPROM. All of these memories will be talked in next slides in detail. It's including input-output ports. As you see, these are input-output ports for interfacing with different applications as LCD, keypads, and so on. It has it's also including timer counter for counting the events, and for different application, for different users and tests can be used. Also, it is including CPU, which is the main of our microcontroller for processing data, and all of the peripherals are connected actually to our CPU inside our microcontroller. It's including interrupt sources, and also it has interrupt control for creating interrupt. It is including analog to digital and digital to analog functions or converters. The main peripherals as input output ports, different memories, CPUs, different components, or will be talked in detail in next slides. Yes, I'm starting with CPU, which is central processing unit of our microcontroller. I have a question. Do you want to have a break or you want to continue and finish the session? What's your idea? Okay, very nice. I actually prefer to continue and finish the course because uh, this is online class, and after having a break or interrupt, most of the students wants to get rest and don't come back to the class. Anyway, um, what are the microcontroller components? As we talked in diagram in previous slides, it's including CPU. CPU is central processing unit, and actually, as I said, and as I repeated more and more, is the brain of microcontroller and any kind of computer. CPU is responsible for fetching the instruction, then decoding it, and finally executing it. Then the three main steps are actually done inside the CPU. One of them is fetching, the other decoding, and after that executing the construction. Actually, CPU connects every parts of microcontroller into a single chip, as I shown for you in previous slide. The primary function of CPU is fetching and decoding instruction, as I talked about it, and the instruction fetched from the program memory must be decoded by CPU. Also, when we are talking about the CPU is including some components. One of the main components related to CPU is registers, program counter registers, file registers, and all of them are inside the CPU. I'll talk about the registers in next slide, but about the other elements that you see here, ALU and CU, which are the main parts, main components of CPU. Now I want to talk about them. What is ALU, which is placed inside CPU? These components aren't related to microcontroller itself. They are actually related to the CPU, which is placed inside our microcontroller. ALU is arithmetic logic unit, and briefly it is called ALU is a combinational digital circuit that performs arithmetic and bitwise operation. And about CU, which is abbreviation of control units, control unit actually decodes the instruction and controls all the other internal components of CPU to can work. But about the register, which is considered as a component of CPU and it's placed inside the CPU, is a quickly accessible location available to a processor and is one of the small set of data holding places that may hold an instruction. It can hold an instruction, a storage address, or any kind of data. Then it is a location for storing the instruction, address, or any kind of data. There are different types of registers inside our CPU. Accumulator register, it is a register in which intermediate arithmetic or logic results are restored. We have flag register, it is a statue register, and the value of these bits indicates some conditions that result after execution of an instruction. For example, about ZF flag register, if the result of instruction after executing that will be 0, then ZF flag would be equal 1. Or we have another type of register, condition register. It is determining the negative and positive status. For example, if the sign of the instruction after executing would be negative, then SF flag register value is equal 1, meaning that if it is equal 1, then the instruction result sign would be negative. But what is program counter on instruction pointer register? It indicates where a CPU is in its program sequence. It's related to the sequence of our programming and contains the addresses of next instruction, with meaning that along executing the program, a unity added to the line of the number of next instruction. That is completely related to the counting of program and along our execution, a unity added to the line of next instruction. Now, the other components of microcontroller, we passed the CPU part. Now we will pay to different other components of microcontroller, which one of them is memory types. Different and several memories are in a microcontroller, and different types of memory which are divided into RAM. You know that it is a briefly abbreviation of random access memory, which is a volatile memory. The other is ROM, read-only memory, and flash memories, which are non-volatile. ROM and flash memory are non-volatile. Then we have three types of memory inside our microcontroller. We have exchanging of data, which are placed in different locations related to memories of microcontroller. Now I want to talk, please refer to a dictionary to find the volatile meaning. About the RAM, which is random access memory, we have two types, static and dynamic RAM. At first, I talk about static one and different types of that, and then I'll talk about dynamic type and different categories of dynamic type. About static RAM or static random access memory, it is very expensive, and also it's really high performance and constructed of flip-flops. But about dynamic RAM, it is cheap, constructed from capacitors, so it needs to be refreshed periodically for charge and discharge the capacitors. It is divided, this type, dynamic type, it's divided into SDRAM, synchronous dynamic random access memory, which synchronous type also is divided into SDR SDRAM or DDR SDRAM. Actually, DDR SDRAM, with respect to the others, meaning that SDR has better performance and faster, and it's commonly used in our computers, and also in microcontrollers. What about the read-only memory? We have different types of ROM. One of them is ROM itself, the other PROM or programmable ROM. The other is EPROM, raisable programmable by UV light, which is not used mostly nowadays. And the next one, which is the best one, is EEPROM, which is electrically raisable, programmable, read-only memory. These types is mostly used in our microcontroller and computers and any type of memories. The other kind of the memory, which all of us are familiar with, that is flash memory. It is non-volatile computer memory that can be electrically erased. You see that it's not erased by UV. It's also, as EEPROM is electrically erased, and it is reprogrammable. It is a technology that's primarily used in memory cards and USB flash drives for general storage and transfer of data between two devices, between two computers, between computers and other digital products. It is a specific type of EEPROM. As I said, it is electrically erasable programmable read-only memory, and it's raised and programmed in large blocks. If you want to compare flash memory and EEPROM, actually, flash memory is so faster than EEPROM. Okay, I think it is our last slide, and I want to talk about the last main components of microcontroller, which is input output ports. They are actually parallel input output ports, which are mainly used for interfacing different applications and devices such as LCD, LED, keypad, printer, memories, and etc. To our microcontroller. Then we are using our input output pins or ports for having interface with our required applications and different types of devices for exchanging data between that devices, that applications, and microcontroller. Okay, today session actually by explaining about the microcontroller and the different components of microcontroller, the difference between microprocessor and microcontroller is finished. If you have any question, I'm here to answer you. Don't hesitate if you have any question, but please don't interrupt the class when I'm teaching. So any question? Do you have any question? Okay, I think as I talked about it in previous session, the first parts of microcontroller and microprocessor course is somehow explanatory, and it would be somehow boring for you. But after passing three session, I think we will start to coding. That's a really interesting and exciting part of our course. So please be patient to pass this part, explanatory part of our course. And next steps, it would be so grateful for us. Thank you very much. Have a nice time. I'll share the material with all of you by OIS. Thank you. Have a nice time. Bye-bye.